While this feels like a very efficient way to find a greatest common factor, a problem that students experience is they accidentally forget one of the factors when they're listing them all out. So I'm going to teach you an additional strategy that you can try. I'm going to turn to a fresh page so that I have more room. I'm going to show you an example and then I'll talk about the steps. But before I get started, I am going to write a new focus so that I'm able to find it later if I need it. And my focus on this page is going to be GCF with prime factorization trees. And I'm going to put trees in quotation marks. For this problem, or the way, sorry, not problem, for this strategy, I'm going to give myself 2 examples. And then I'm going to list my steps at the bottom. Because this is a very new way to solve, I'm going to show you a couple of examples, and then we'll talk about the steps that we took and list them out. So for example 1, I'm going to find the GCF of 27 and 18. And this is what I feel like is the funnest way to solve. I'm going to start out by putting 27 and break it into what I call branches. So that's my top number. And it's going to split or branch into a factor pair. I know that 3 times 9 will give me 27. 3 is a prime number, and I'm going to circle it. Now I know that 9 could break down even farther because it could be factored into 3 times 3. Both of those are prime numbers, and so I circle them. Now I have a prime number at the end of every branch, so I know I'm done factoring 27 into its prime factors. And this is where you can check your work. I can check to see if I did it correctly by writing 27 equals 3 times 3 times 3. And if you remember, I use a dot to show multiplication. It means the same thing as the little x, it's just neater in this situation. So 27 equals 3 times 3 times 3, and I can check it. 3 times 3 is 9, 9 times 3 is 27, so I know I did it correctly. Those are all the prime factors of 27, and just in cool math, our prime factors will multiply to give us our number. Now let's try 18. All right, 18 at the top. There's a couple ways I could split 18, but I'm just going to start by splitting it in half. 2 times 9. 2 can't be broken down any farther, it's prime, so I'm going to circle it. 9 can be split into 3 times 3. They're prime, so I circle them. And then I have nothing else I can break down. So 18 is equal to 2 times 3 times 3. I check my work. 2 times 3 is 6. 6 times 3 is 18, so I know I did it correctly. And now I'm ready to find the greatest common factor. To do that, I'm going to look and see which prime factors they have in common. I see that 27 has a prime factor of 3, and so does 18. So I'm going to circle it because they share it. This one has another 3, and so does that one. So I'm going to circle it. 27 has one more 3, but there's not one in 18, so I can't circle that one. 18 has a 2, but there's not one over in the 27, so I can't circle that one either. The only prime factors they share are 3 and 3. So my GCF is going to be equal to 3 times 3, or the 2 prime factors that they have in common. So in this case, my GCF is 9. Let's try it one more time and then we'll list out our steps. Let's do another example. Let's find the GCF of 30 and 24. I'm going to start with 30, my first value, and I'm going to split it or branch it into two factors. Again, there's a couple ways I could go about this one. I like to split even numbers in half. That's just my preference. I'm going to start with 2, which is prime, so I'll circle it, and 15. Then I know 15 can be further broken down or branched into its factors of 5 and 3, because 5 times 3 is 15. 5 is prime, so I circle it. 3 is prime, so I circle it. And then I can check my math by writing it out as 30 is equal to 2 times 5 times 3. 2 times 5 is 10. 10 times 3 is 30, so I know I did it correctly. Then I'll go over to 24. 24 can branch, it's also even, so it could divide in half to 2 and 12. I could have done different values. I know there's a lot of factors of 24, but again, that's just my preference. I circle 2 because it's prime. 12 can split into factors of 2 and 6. 2 once again is prime. 6 can split into 2 and 3. And now I've reached the end of my branch. If you can see, all of my branches end in those circled prime factors. Now 24 will be equal to all of my prime factors multiplied together. 2 times 2 times 2 times 3. And I check it. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24, so I know it's correct. And then I can find my GCF by seeing what they have in common. I know that they share a 2. They also share a 3. So my GCF is going to be 2 times 3. Again, those prime factors that they have in common. So my GCF is equal to 6. Now I'm going to list out the steps. Rather than writing important to remember, I'm just going to write steps. And I'm going to number them and list them off. If you recall, our first step was starting each tree. So start each tree with the number. So whatever number you're working with. Step 2, break, or you could put branch, either word works. Break the number into 2 factors. You can use whichever factors you prefer. 3, you're going to keep breaking down each factor until you only have prime, I'll go right here, prime numbers at the end of each branch. I'm putting branch in quotes because it's not a real branch. While I work, I'm going to circle the prime numbers. That's how I form my trees. The last couple steps are how I find the greatest common factor. 5, I'm going to write out the equation for each number. If you remember, that's what we did up here. We wrote out the equation for each number. Then I circled the numbers they have in common, which are their common prime factors. I'm running out of space. It's okay, it's my last step. The GCF is the product of their common prime factors. Now you're ready to try it on your own.